Okay, so notice I'm in the data view down here. You can click that. That lets us see all the individual data. And ironically, the reason we're going to all these numbers is so that we can bring the numbers to life and see that we're talking about actual humans here. We do want to make sure that the student we choose or the participant we choose does have data on our two variables. So for me, that's statistics GPA. You can kind of flip through there a little bit if you want and just choose someone that does have data. So it has on statistics GPA and on persistence there. If it's a negative number that's an integer like 0, 0, 0, that's missing data. If it's a negative number with some decimals there, that's legitimate. It was probably just a variable that had negative values on. So choose any student in this data set that has data on both your x and your y variable. For me, I'm choosing student 152220. So at this point, they're very impersonal. We want to find out a little bit about them. So here we see that their race was a 7. Using the instructions that I gave you or the code book, you can find that 7 represents white. So we know the race of this participant is white. Going to the base year sex, a 2 represented female. Again, I put that in your instructions or if you go to the code book. So we're talking about a white female here. Birthday month, so the first 4 of the year, 1986. The next is the month. So we're talking about a white female born in January of 1986. Slowly starting to come to life as an actual person. This female, very, very good chance that she is alive and somewhere in the world as we speak right now. If she was born in 86, you can figure how old she'd be in her 30s. And we could find out all kinds of stuff about her here by looking point by point, but that's enough for now for this assignment. What we want to move to now is the persistence level. So her persistence level was a 1.112, and roughly speaking, the average persistence was 0, so she had a little higher than normal persistence. So let's go ahead and use that and record that in the report and also make a prediction using our regression equation of what her statistics GPA would be, and then we'll compare it to what it actually was. Okay, I've just summarized what I said so far. We want to get her predicted GPA now. So again, her persistence score was a 1.112. That was her actual score. Using this equation that I came up with here, we can get her predicted statistics GPA by taking 2.806 plus 0.151 times 1.112. So we're basically just subbing this number in for persistence. And by order of operations, we need to multiply these two first and then add it to this baseline GPA. So if we do that, we would get a predicted GPA of 2.97. Now that's her prediction based on this regression equation here. But we can actually see what her statistics GPA was, right? So again, using that same student, we're going to slide all the way over and see that she had a statistics GPA of 3.00. So we'll put her actual was 3.00, meaning that her residual was, and here we're going to take the observed y value and subtract the predicted. So her observed y value was 3.00. We're going to subtract out what the predicted was, and we get 0.03. That's how far we were off. This was our prediction based on knowing in high school that this was her persistence. So take note that we could have, if we had this regression equation, which is for the entire data set, as soon as we knew that this girl had scored a persistence score as her sophomore year in high school, already we could have made a prediction about her college statistics GPA. We would have predicted her as getting a 2.97, and we would have been very close. Now, this was, I think we just happened to get someone where the regression equation was very good and the residuals very small. Because our effect size was not big for this model, you would also have many students whose residual are much higher. But for this particular female, it did happen to give a good prediction. Okay, and the final thing we want to do here is play a little bit of what if, and we're going to base that, the whole point of this is to get a sense of what this slope number actually means. So we're going to say, if her I'm going to capitalize this to be consistent, persistence score had been 1 unit higher. So in other words, instead of a 1.112, she had a 2.112. Her predicted would have been, so you're going to do the same thing that you just did, except instead of plugging this number in for persistence, you're going to raise whatever your number is, raise that by 1 and plug it in the equation. In other words, you're going to add one more of this slope into the predicted value. So the predicted value I know was 2.97. It's going to go up by this amount. Okay, so you can either add this slope amount to your original prediction, or you can raise this by 1 and put it into the equation. They should give you the same answer. In my case, it's going to be a GPA of 3.12. So for every additional unit of persistence that they go up, the idea is the average predicted score will go up by 0.15. And for every unit that we would go down in our value on persistence, so if she had had a 0.112, we would expect that her predicted GPA would also go down by this amount. So the slope is how much the predicted Y is changing, either going up or down, depending on the values of this persistence variable. For every 1 unit increase in this persistence, or whatever this X variable is, we would predict this much increase in the Y.